Alright, now we're going to have a look at an area bound by the curve x squared take 1, x squared take 4. It's going to be a bit squishy. Notice that I have given myself 3 columns. If you're not comfortable working in a squishy environment, do it in your book. We don't know which part of this graph is above the x-axis, which is below the x-axis. If you don't know that, you need to begin the problem by sketching the function. Okay, Tech Active, you can put it in your calculator, get it graphed, and then copy the graph and label your areas. Tech Free, you're going to need to find your x-intercept, your y-intercept, see what's happening as x goes towards negative and positive infinity, and then sketch the function. So I'm going to assume that this is Tech Free. So I'm going to say I get my x-intercepts. And I can see that this can be rewritten as x take 1, x plus 1, and x take 2, x plus 2. So using my null factor law, I know that x equals 1, negative 1, 2, and negative 2. So my x-intercepts are then going to be negative 2, 0, negative 1, 0, 1, 0, and 2, 0. My y-intercepts occur when x equals 0, so I have y is going to be negative 1 times negative 4, which is positive 4, and so my y-intercept is at 0 and 4. I still don't really know what this thing looks like, but if I have a look as x tends towards negative infinity, if I put a really big negative number in here and I square it, I get a big positive number. And if I put a really big negative number in here and I square it, I get a really big positive number. So then a big number minus 1 is going to make no difference, it's still positive, and a big positive number minus 4 will also still be positive, and a positive times a positive is positive, so y also tends to positive infinity. If I look as x turns to positive infinity, big positive squared, very big positive, minus 1 make no difference. Big positive squared, very big positive, minus 4, no difference, positive times positive, and y tends to positive infinity. So what that tells me is this thing begins somewhere up here and ends somewhere up here. So that's cool. I can now say, well, that means I know I must have a function that goes down there. There's a turning point somewhere there. There's another turning point. There's another turning point and goes up there. And what's really cool about that is I can then see, well, I've got an area under the curve there, an area under the curve there, and one there. Now, 2 ways we can approach this. The first way is I can say, well, I'll add area 1 to area 2 to area 3. My 2 negative ones which are below, so I must remember to have negative integral. Or what I can say is I know that this is a symmetrical shape because I know that my even powers have got symmetrical functions, and so I can just integrate from area 1 and area 2 and then double it to get my total area. Okay, if you choose to do that, what you need to do is tell me that you're using symmetry and acknowledge what you're doing. Alright, so we're going to go up here and we're going to say using symmetry, area 1 plus area 2 equals area 3 plus area 4. So therefore my total area will be 2 times area 1 plus area 2. Okay, so you're communicating what you're doing. And we can say, therefore, my total area. Now we need to be careful because our negative area is below the x-axis, and I'm going to have a negative integral there. Okay, so I'm going to have 2 multiplied by a negative integral from negative 2 to negative 1 of x to the 4. Oh, and I had to expand it because I don't have a rule to integrate the two functions multiplied by each other. X squared plus 4 dx, and to that I'm going to add my integral from negative 1 to 0 of x to the 4 minus 5x squared plus 4 dx. And I'm going to do my integration, so 2 multiplied by, still keep my negative out here for now, x to the 5 over 5 minus 5x cubed over 3 plus 4x, and that's going from negative 2 to negative 1 plus x to the 5 over 5 minus 5x cubed over 3 plus 4x, and that one's going from negative 1 to 0. And I think it's a bit easier now before we do our substitution that we just multiply that negative in. So I have 2 times, and I've got negative x to the 5 over 5 plus 5x cubed over 3, 4x, from negative 2 to negative 1, plus, I'm missing a bracket here. Let's make sure that we're multiplying everything correctly. And we just got x to the 5 over 5 minus 5x cubed over 3 plus 4x between negative 1 and 0. Alright, now we can substitute our limits of integration in. And we still have our 2 there. 2 multiplied by, and we have 1/5 minus 5/3 plus 4 minus 32 over 5 minus 40 over 3 plus 8, and to that we are adding 0, take negative 1/5 plus 5/3 minus 4. And I'm going to need to get some lowest common denominators. So I have 3 minus 25 plus 60 over 15 minus 96 minus 200 plus 120 over 15. And to that I am adding 0, take negative 3 plus 25 minus 60 over 15. Can you see how important it is not to mess up your signs? Okay, and then we have still 2 multiplied by, maybe we can get it onto one line now, 38 over 15 minus 16 over 15 plus 0 minus negative 38 over 15, and that's going to be 2 multiplied by 60 over 15, and when we work that out we get 8 square units.